So the base is a circle because we spun around the x-axis. Now, not a trick question. If I want to find the area of a circle, what's the area formula for a circle? Area is equal to what? Pi r squared. Now, this is going to be nice, at least today, because we're going to keep things simple. What is the radius of this circle? So do you guys see how we're spinning around the x-axis? So do you guys agree this is the equation y is equal to 0? What is this equation right here? Y is equal to what? X squared. So do you guys agree that this right here would be the center of this circle? The radius would be the distance from 0 up until I touch the function. So if I'm thinking about what we've been doing, haven't we been doing top function minus bottom function? The radius of this circle then, guys, is just the outside function. It's just the parabola, okay? So for reasons that I just know things, we're going to call this radius specifically capital R of X. So the radius is whatever your f of x is. And so in this case, we're going to call it the outside function. So we're going to call it R of x. In this case, it's going to be x squared because it's a quadratic. So then the area of one cross section is going to be pi r squared. So it's going to be pi times our radius, which is capital R of x squared, which is equal to pi times, what was our radius? X squared. And then do you guys agree I could simplify that if I want to? Okay. So if that's the area, or sorry, if that's the volume of one cross section, how do I find the volume of all the cross sections? Which calculus operation do I need to do? What have we been doing for 2 months, guys? You guys are embarrassing me. Take the integral, right? So every possible cross section the formula is going to be v is equal to the integral of 0 to 2, because that's our bounds, of pi times x squared dx. All right. So in general, until tomorrow and Thursday, this is how you find the volume of the solids. The formula is going to be the integral from a to b of pi times your big radius, capital R of x, squared dx, where capital R of x is the distance between the axis of revolution and the outside of the solid. Fun. Oh, nice. Just washers and this. But they have to do differential equations after spring break and slope fields. Yeah. All right, so a couple examples. take the region bounded by y is equal to e to the x, y is equal to 0, x is equal to 0, and x is equal to 3. Revolve this region about the x-axis, so that's important. Find the volume of the solid formed. Okay. Now, one thing your answer or the directions don't say is for most of these problems, we want to leave our answers in terms of pi, which means for most of these problems in this section and until we test, we're not going to be able to use our calculator to calculate the volume. Okay, so do these have to be perfect graphs if I'm going to sketch this? No. So do you guys agree that e to the x is just an exponential graph? So it looks something like that. So I'm going to try to do a rough sketch of what that looks like. So something like that. Does anybody know what that point is right there? 1, good. So if I plug in 0, what's e to the 0? 1. X is equal to 0, do you guys agree, is this boundary right here? And then x is equal to 3 would be this boundary right here. I'll make that look better. And y is equal to 0, so all right. Together, we're going to actually practice sketching what this looks like. Because what are we spinning it around? The x-axis. So this is important because whatever axis it says that you're revolving around, this means that our integral is going to be dx because it's with respect to x. Okay? So that means that we don't have to do anything extra. I don't have to solve for anything here. So the first thing that we're going to do, I'm going to refresh your memory. I'm going to scroll up real quick. The parabola was right here, right? This boundary. The first thing you have to think about is if I spin it around the x-axis, it's going to be mirrored down here. And then whatever shape it creates, it's going to basically, we're going to draw like a circular base like that. So do you guys see how this part of the boundary is this shape right here? If I spin it around the x-axis, it's going to create a mirrored version of that right there. So I'm going to sketch something like that right there. So this is going to be the bottom part of my my solid. This is going to be the upper part of my solid. Now, since we're spinning around the x-axis, basically this right here, between this point and this point, is where I'm going to start creating my circular base. So it's going to look something like that. I don't know if you guys can see I drew little dotted dashed lines to represent, kind of like to make it look 3D-ish. Okay. So how do I set this up? The integral is going to be from a to b of pi times r of x squared dx. Okay, is everybody, but hopefully try not to freak out about the drawing. The math part is hopefully not as bad. What's the lower bound of this integral? Where do we start? 0. And where are we ending? 3. For all these problems, this is just a constant technically, right? Where could I put this? on the outside. So I'm just going to take out the pi. We don't really care about the pi unless it's Friday. Don't forget Friday's pi day. All right. Now, r of x, remember, is our radius, our big radius. And until tomorrow and until Thursday, it's really easy. We're revolving around the x-axis, right? So this is just 0. So it's really just this function minus 0. What is this function right here? E to the x. E to the x minus 0, do you guys agree is just e to the x? So it's just going to be e to the x squared dx. Okay, here comes the fun part. We're now going to integrate this by hand. So let's simplify. E to the x squared, power to a power, multiply the powers. So this is going to become pi times the integral of 0 to 3 of e to the 2x dx. Now, I am going to use substitution. Because I have 2x, do you guys agree the integral of e to the x is just e to the x? But because it's e to the 2x, it's a little bit more complicated. So I'm going to do u substitution. So that's going to be my u. What do I do next? Take the derivative. So what's my du? 2 dx. Do I have an extra 2 floating around here? But I have a dx, right? So how do I get dx by itself? What do I do? Divide by 2. So then 1/2 du is equal to dx. Is everybody cool with that? So I'm not going to write e to the u anymore. I'm going to write, e to the 2x anymore. I'm going to write e to the u. So I'm thinking ahead. So this is going to become pi. I'm taking out a 1/2 also, right? Because this is a constant. So do you guys agree pi times a half is just pi over 2? Of e to the u du. Now, I have to remember, though, that I'm not integrating this in terms of x anymore. So do you guys remember, in this case, I have to change my bounds. So if I plug in 0 in for x, guys, what's 2 times 0? 0. So this is going to be 0. If I plug in 3, what's 2 times 3? 6. Okay? Now, we like this because what's the antiderivative of e to the u? It's just e to the u. So this is going to be pi over 2 times e to the u from 0 to 6, which is going to be pi over 2 times, if I plug in my upper bound, I'm going to get e to the 6th, minus, if I plug in my lower bound, I'm going to get e to the 0. What's anything to the 0 power? 1. So this is my exact volume. Now, the homework's going to tell you guys to leave your answers in terms of pi, right? So technically, like on a test, you could still check this on your calculator, right? Because is this going to be a pretty answer? You're going to get a decimal, right? If you type this into your calculator and then integrate it with your calculator, you guys should get the same answer. Okay. Questions? All right. That was so much fun. Let's do one more. So now I'm going to revolve it around the y-axis, which means what's going to be my integral dy. Okay, so before we figure out the function, let's go ahead and graph this first. What type of function is this? Linear. So do you guys agree it's a line that the y-intercept is 4 and the slope is -2? So I'm going to plot a point right here. My rise over run, since it's -2, I'm going to go down 2 over 1 and then down 2 over 1. Since it looks something like that. And then we're also revolving it around x equals 0 and y equals 0. So you guys will see me do this. I'm going to spin it around the y-axis. So that helps you because that means that you guys agree it's going to spin this way. Okay, so talk to me, guys. If I'm spinning it around the y-axis, okay, remember we have to make a mirrored image first. So is that mirrored image going to go down here? Do you guys agree it's going to end up over here? So this one's going to kind of look like a cone when we're done. I'm going to sketch something that looks like this. And then what shape is the base? Circle, right? So it's going to look something like this. Cool. All right. Now here comes the easy part. Remember, because we're revolving around y, it's going to be r of y technically, dy. But we have to be careful because is our function ready to do that? So I have to get what by itself then? X. So I have to solve for x here first. So I'm going to get I'm going to subtract 4. Divide by -2. So this then is my r of y. Because since I'm integrating with respect to y, do you guys agree it's going to be right minus left? But remember, since we're spinning it around the y-axis, what is the equation here? X equals 0. So do you guys agree this minus 0 is just going to be that? Okay, so there's no extra thinking here yet. I'm trying to keep things simple so you guys just get used to the formula. Okay? All right, so plugging it into my integral, remember you can take out the pi. Since I'm integrating with respect to y, what's my lower bound? 0. What's my upper bound? 4. Good. So this is going to be -1/2 y plus 2 squared dy. Now you guys could do a couple things. If you're really lazy, you could do u substitution here if you really wanted to. Or we can just multiply this out. Do you guys agree that this means this times itself? Okay, so if I multiplied everything out, I'm going to get -1/2 times -1/2 is going to be positive 1/4 y squared. Then if I expanded it and multiplied, I would get what? Negative y, so -2y plus 4 dy. Let me double check, because I don't want to keep going if I'm wrong. That's right? Yeah. Okay. So if we're integrating this now, remember you're going to add 1 to the power and then divide by the new power. So this is going to be pi times. Do you guys agree that that's going to be y cubed over 3? But since I'm multiplying by 1/4, it's going to be y cubed over 12. Minus, if I integrate negative 2y, it's going to be just y squared plus 4y from 0 to 4. Now this is nice because if I'm thinking ahead, guys, if I plug in 0 to all these, what are those going to become? 0. So the 0 here we don't have to worry about. So I just have to plug in 4. So this is going to be pi times, if I plug in 4 cubed is 64, minus 16 plus 16 what happens to these? It's cancel. And then if I want to reduce this more, I could, because what goes into 64 that also goes into 12? 4? How many times does 4 go into 64? 16? How many times does 4 go into 12? 3. So the exact volume of this shape is 16 pi over 3.